Are Docker containers and images actually different? Imagine building a house from a blueprint and then actually constructing the house. The blueprint is like a Docker image, and the house you build is like a Docker container. They are connected but serve different purposes. A Docker image is a static, read-only file that contains everything needed to create a container. It includes the application code, libraries, dependencies, and configuration files. Think of it as a detailed recipe or a snapshot of an environment. Developers create images using a Dockerfile, which is a set of instructions on how to build that image. Once built, images can be stored locally on a computer or uploaded to a remote registry for sharing. They are unchangeable once created, meaning you cannot modify an image directly. Instead, you create new images based on updates or changes. A Docker container is a live, running instance of an image. When you start a container, it uses the image as a template but becomes an active environment where the application runs. Unlike images, containers are mutable, so you can make changes inside them while they are running. For example, you can write data, install new software, or modify configurations. Each container has its own file system, network settings, and processes, which are isolated from other containers and the host system. You can think of containers as the actual application environments that you interact with, while images are the blueprints used to create those environments. In terms of deployment and scalability, images are essential because they ensure that every container launched from the same image will behave exactly the same. This consistency is key when deploying applications across multiple servers or cloud environments. Containers make it easy to scale your backend services because you can run many instances of the same image simultaneously. This helps handle more traffic or workload without complicated setup. Containerization and orchestration tools like Docker Swarm or Kubernetes help manage these containers at scale. They coordinate how containers are started, stopped, and balanced across servers. This setup makes your backend more reliable and flexible. For example, if one container fails, the system can automatically spin up a new one from the same image to replace it. Understanding the difference between Docker images and containers helps backend developers streamline deployment processes. Using images guarantees environment consistency, while containers provide the flexible, isolated environments needed to run applications smoothly. This combination makes managing backend services more straightforward, scalable, and dependable.